Okay, so yesterday we are having a very brief introduction about the errors. What kind of errors aligns for your measurement in the surveying project? And we see that there will be three types of the errors: the gross error, the systematic error, and also the random error. The random error is the most difficult part that we need to handle. In order to measure the random error, we will first introduce a random variable, and we say that random variable would be a variable which will contain several possible values, and each one will have a probability. We also introduce the definition of the probability, and as we showed in the example about flipping the coin, if you have 100 times for the experiment and you get a 53 as the front and 47 as the back, then you have the probability of the front as 53% and the back as 47%. So the percentage is determined by the total number of the frequency for that result over the total number of the total number of the experiments. And with that, we get the percentage as 53 and 47 for the two results. So that's what we stopped last time, and let me try to stop using the timing. And when we are talking about the random variable, we usually connect this one, the probability, with the statistics. We have a lot of observations in reality from a group of the samples, and this will refers us to several concepts, which is called the population and sample. The population is defined as the total number of all possible values of the random variable. And the sample represents a set of the values or set of the observations selected from the population. And usually the population will contain a very large number of objects, and it's impossible for us to check the values or check the possibilities of every object. So in order for us to understand what's the features of the population, what we can do is like we just randomly select a set of the objects which would be the sample from the population, and do some analysis about the samples. And as the number of the objects in the sample is small, it will be available for us, and it's possible for us to analyze all those data in the sample. So the method for us to do the to process and analyze the sample is called the statistics. And there will be three features for us to represent the sample, which would be the histogram, the location, and dispersion. I will help you to go through each one. First, for the histogram, this one actually shows the distribution of the values from the sample, and it will also represent what's the distribution of those values in the population. For example, if we consider if we want to find out the distribution of the height for the students across the whole university, say that at McMaster, there might be more than 20,000 students at McMaster University. So it's impossible for us to get the height of all the students. But if we still want to find out some information about it, what we need to do is like we will select a set of the students from the entire university randomly. For example, say that if we select 20 students and we measure their height. So the table here just shows the height of each student. As we only have 20 students, we are able to complete all the measurements. And then we have the results. The student 1 with the height of the 179 centimeters, student 2, 167, and so on. Then we need to know how to conduct the histogram. So at first, I will just show you the what's the histogram for the student height. So this is actually the student height distribution, which is the histogram from the previous sampling results. And the way for you to identify or to find out this histogram is like you first need to identify the bins. So the first step, find out the bins. We can say that the bin will be around with the interval of the bin is 5 centimeters. So to identify the bin, we need to check the range of the range of the height. Like for this sample, the minimum height will be, if we go to check all the value, will be 161 centimeter, and the maximum will be say if we go to check all these values, the maximum will be 190. So this will be the maximum value. And we can then set an interval, which is around, which would be the bin size, as say around 5 centimeters. And now we can then go to check the specify the bin. For each value, we can say that the bin value will be bin 1 will be 160 to 165. Bin 2 will be 166, maybe 161, that will be easier. 166 to 170. 3 will be 171 to 175, and so on until you get the last one, that will be 185 to 190. So this would be the maximum value, and that would be the minimum value. And now you will have a set of the bins, and the next thing you need to do is to check how many samples are forced in each bin. So for the bin 1, we say it's 161 to 165. If we go back to check the values, you can see that there are only 2 values forced in that one. So this one, the sample 13 and sample 19, and that will give you the total number in that bin as 2. So we only have 2 values. And then from 166 to 170, 160 between 166 and 170. So we have 1, 2, 3, and you need to go to check all the possible values. So we only have 170, 4, and 5. So we have 5 values. And that's what you get for 5. And similarly, you can find out the other one, 3, for the other bins, 3, 6, 3, 1. So then with all these values, with the bin numbers and also the number of the samples in each bin, you can draw the bar for each bin, and this one is just called the histogram. And that's the way for you to draw a histogram for a sample, and shows the distribution of the sampled value. So any questions so far? So if no, I just assume that you know how to create a bin. Okay. Now the bin, how to create a bin and generate the histogram. Actually, the histogram is just one way for you to show the to make a statistic about the sample. The next thing we want to identify from the statistical analysis is the location of the sample and also the deviation. Generally, the location of one sample will be represented by two variables. The first one is defined as the mean, which is also the average value of the sample. For example, if we have n observations and we have the value of each one will be x1, x2, x3, x4 until xn. So those will be the n observations or n measurements that you conducted. Then the mean value will just be the average of these n values. So do the summation about all the observations and divide this one by n. That will be the total number of the observations, and that will give you the mean of the sample. And for example, if we still go back to see the still a high example, we have the total number of n. We have n as 20, which means that we have 20 observations. And in order for us to find out the average height or the mean height of the students, we need to use the definition of mean. So that would be the summation of all the observations I will from 1 to n divided by the total number of the observations. So in this case, we have n equal to 20. So that is a summation of xi from 1 to 20 divided by 20. So that is x1 plus x2 plus x3 plus x4 until you get to x20 divided by 20. If you put all the values in this equation, eventually you can find out the value of the mean as 174.7. So that's the mean of the of one sample, and it's also the way for you to do the calculation. The other way for you to measure the location of the sample or the observations is like it's called the median. Median will actually represent the value, the middle value of sample. So to find out the median, you should first sort the n observations from the lowest one to the highest one. Still, if we say that there will be n observations, and we will do the sorting for this observation, the smallest one would be x1, and x1 definitely should be smaller than x2 and x3 until you get the largest one, xn. If n is odd, then we will have the median as the middle value. The middle one, that x would be the median would be x, and the index will be n over 2 plus 1. And if that would be the even, then you have to find out the two values in the middle and find out the average value of these two. Let me just show you one simple example about how we can find out the median of the observations. We will start with a very simple one. So example 1. Assuming that we have 5 observations, so n equal to 5, and the observed value would be 3, 1, 6, 7, 7, and 4. Now, in order for you to find out the median of these observations, these n5 observations, what we need to do is like first we have to sort those observations, these 5 values, from the smallest one to the highest one. say that we have the smallest one would be 1, and the second smallest one would be 3. If we do the sorting for these 5 values, we have 1, 3, 4, 6, 7. And this is x1, this is x2, and this is x3, and this is x4, and this is x5. So for the median, x median will be x, that will be half n plus 1. So this part always gives you the lower integer from this division. So that is x given 5/2 plus 1. So 5 divided by 2, that will be x2 plus 1, that is x3. So in this case, x3 is 4. So the median would be 4. That would be exactly the one in the middle. So that's the case when the total number of the observation n is odd. But if n is even, say that we added another observation. We added the observation 9, and now you have n equal to 6. We have 6 observations, and you sort them from the smallest one to the highest one. 1, 3, 4, 6, 7, and 9. And that would be x1, x2, x3, x4, x5, and x6. Now we know that the total number of the observation is even. So what we can find that for the median, x median will be xn/2 plus xn/2 plus 1 divided by 2. So n equals to 6. What we will get is the first one would be x3, and the second one would be x4 divided by 2. Then you will have the average value. That is x3 is 4, x4 is 6 divided by 2. So it gives you the median as 5. So that's the way for you to find out the median of the sample. And again, we can go back to the student height example. So the first step we have to do is like we need to sort n equal to 20 observations from low to high. And then as n equal to 20, this is an even number. So we need to find out the value of xn divided by 2 and xn divided by 2 plus 1. So that is x10 and x11. So that's the middle values from this observation. And in the third step, the median will be x10 plus x11 divided by 2. So if you find out this median value, these two middle values, the 10th mid value would be 175, and the 11th of 177 divided by 2, that will be the 176 centimeters. So this is the way for you to find out the median value of the student height from the example. So that's the that will be the calculation about the median. I will pause a little bit here. Do you have any questions?
Yeah, I have one question.
Yes.
For the previous example, how did 5/2 become like 3, and then you got 4?
Oh yeah, the so I guess you are talking about this one, right?
Yeah.
This value. This will give you the rounded. It's not the rounded value. It will give you the lower end of the integer. So if you have n equal to 5, so n divided by 2, that will be 5 over 2. So you just take out the integer part, not the rounded value. So this is just pick up the integer value instead of the round value. So just take out the 2. So it's a flaw of the integer instead of the rounded value or the ceiling, just the flaw.
Okay, thank you.
Okay. 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 Then that's the let's go to see the next one. The next variable for us to evaluate the feature of the sample is called the dispersion. It shows that how wide the samples are distributed around the mean value or around the median. So basically, we're gonna use still similarly we will have two variables, which is called the variance and deviation. These two are actually quite similar to each other. The variance, as defined, we need to use this equation to define the variance. That will be the summation of xi minus x bar. X bar here is the mean of the sample. And we do the summation of the difference between the observation to the mean of their square divided by n minus 1. Remember that the value at the bottom should be n minus 1, not the observation. And this will give you the variance. With a larger variance, it means that the observation will be, a lot of observations will be far away to the mean value. If the variance is small, means that they are more concentrated to the mean value. And the standard deviation is very simple. It's just the square root of the variance, so which would be the square root of s squared. So that's the definition of the variance and a standard deviation. And again, we can consider the example of the student height. Say that we have the observation, number of the observation as 20. The mean value x bar is 174.7. So that's what we calculated previously. Actually, at every time you do the calculation for the variance, you need to calculate the mean value first. And then for the variance, s squared, that will be the summation of I from 1 to n xi minus x bar squared divided by n minus 1. So that will be I from 1 to 20 xi minus 174.7 squared divided by 20 minus 1. So with that, you just apply all the values from your observation in this equation. I have conducted the calculation before the class. So if you're interested, you can do the calculation by yourself, or you can use Excel to do the calculation. Well, even though Excel gives you some functions, some command for you to get the variance directly, but I still recommend you to do the calculation by yourself, step by step, and compare the value. They should be exactly the same. So based on this equation, we find out the value as 61.21, and that's the variance. Well, once you have the variance, the standard deviation is very simple. S will just be the square root of the variance. So that will be the square root of 61.21. It gives you the value as 7.82. So that's the calculation of the variance and the standard deviation. Any questions so far? Okay. So I'm not quite sure whether the questions you left in the meeting chat is the one you want to check. If you have If you have questions, can you just show us? Can you just show raise your hand to answer the question? Okay, I saw someone want to see how to do it. I think Haibin, do you want to do you have any question?
Yes. Could you show us how to use this find the standard deviation in Excel, please?
Yes. I'll just let me. It will take some time. Just in that moment. Let me try to find out in the same just the Excel file. Or just using some random just some random sample values. So after the class, you can try to use the exact values from the example. Say that I have assuming that we have n equal to 6 values, doesn't matter, just say 6. And now we have the sample. So we have the sample. I just type some random values, 45, 32, 15, 26, and 30. So we have these observations. We have 6 observations, and then you need to find out the mean. Okay, for the mean value. For the calculation of the mean, what you need to do is that you need to do the summation about all these values. So that will be the sum of all the values. So this is the sum of all the values divided by the total number of the observation. In this case, the total number of the observation is 6. So we can see that the mean is 25.3. So that's what we get for the mean from the equation that we have, from the definition. And then you want to find out the variance. Of course, you can find out the variance. If we use their comment, that will be the way for you to find out the variance. We will try to compare our calculation with their comment. So this is from the Excel comment. You get a variance and 203. What we want to do is that we want to do the calculation by ourselves. So first of all, we do the calculation for each one. So xi minus the mean value. So so that's the difference between your observation and the true value and your mean value. And then find out the square of the difference. Again, you can then do the calculation about the variance. So that will be the summation of all these squares divided by n minus 1. So n is 6, 1 minus 1. So what you will get is 203.0. It's the exact same from the comment in Excel. So that's the variance, and the standard deviation is very simple. It's just the square root of the variance. So which will give you the value as 14.2. You can use the same procedure to check the example in our slides. It's the same way. So I think that's the way for you to do the calculation for the mean, variance, standard deviation, and median. There will be some other things I want to cover. I will just try to speed up a little bit. We also need to have some introduction about the lab sessions. So for the measurement of the in surveying, we also need to check what's the quality of your measurement. So there will be three methods, three criterions for you to check your quality of your measurement. That will be the resolution, precision, and accuracy. Resolution is actually related to the smallest division in your instrument, and you will have to consider the smallest division to get the reading from your instrument. And usually there will be two types of the instruments. It could be in digital instrument, with that you will have the reading directly. And you also have some analog instruments which will have the have some scales in the instrument, and you have to read through those scales. If you are using the digital instrument, the resolution would be the smallest division from the instrument as what they displayed. For example, if we are using a total station and read the distance as say that 45.12 meters, then it means that the resolution is a point. The resolution is a 0.01 meter. So that's always the smallest value can be shown in the digital instrument. And if you are using some non-digital instrument, then you need to check the scale. Usually the resolution is also determined by the smallest division, but it could be the resolution will be half of the smallest division. So this one is a little bit different. For example, if we have the ruler or the tape, you do the reading, and you will this will be the scales that you have. You will be reading. You can find from the tape. Say that 40, 41, 42. They are all in millimeters. Then the resolution will be half of the smallest scale that you can find, which will be 0.1 millimeter. No, not 0.1, 0.5 millimeter. So that's the way for you to identify the resolution of digital and non-digital instrument. And usually the uncertainty due to the resolution will also be defined as half of the smallest division from the instrument. So the resolution will determine how accurate, what's the smallest unit you can read from those instruments, digital and non-digital instruments. And the other two types of the measurement will be the precision and accuracy. And this figure, you can see 4 figures here. It will show you how you can identify the observation is accurate or not, it's precise or not. Usually if we don't have any accurate definition about these two terms, a lot of people will just find that these two are the same, but actually in surveying they are very different. In surveying, we have the precision means that the how close are all those variables, repeated observations to their mean values, while the accuracy represents how close the observation is to the true value. They have some difference. For example, for these two results, even though in the second one, all the observations are a little bit away from the center, it still means that this we can still say that these observations are precise because they are all close to their mean values. But for this one, even though the average value of all these observations is close to the center, but it's as it's a little bit far away for all those observations to the mean value, we will say that they are not precise, so imprecise. But it's different for the accuracy. Accuracy will only check the how close the observation to the true value. For the bottom two figures, you can see that this one, the figure on the left has the mean value close to center, but the figure on the right does not. And then we can say that the figure on the right does not have an accurate result, but on the left, it has an accurate result. Well, of course, for this figure, it definitely has an accurate and precise result. So that's the accuracy and precision. We will already have some more detailed definition about precision. So precision will evaluate how much a repeated measurement will be close to the average value they will estimate it. So this would be the range of the randomness will shows how the precision it is. If the range is large, it means that it's not precise. If it's small, means that it's precise. We will only compare with the measured value, the measured average value. And this will be some quantity, some features of the precision. The precision is related to the random errors, and it can cause inaccuracy in the measurement. And usually it's very difficult or impossible to quantify with individual observations. We have to quantify them with a repeated measurement. So that's the reason we need to do multiple readings or multiple measurements for the same quantity in the surveying. This will help us to reduce the potential impact of the random error. And in the surveying, of course, the precision will have very significant impact to the overall quality of your work. If it's not precise, then the surveying will, or the project conducted based on the surveying will have, or even the building is not that stable, or the road will not align to the designed path very well. And the precision and resolution are not different. If you go back to check their definitions, you can clearly see their difference. And sometimes the people are using to replace the precision with the resolution, but as a surveyor, we should not do that. This is not an accurate expression about your measurement. And the last one is the accuracy. Accuracy means we'll try to measure how far the measured value to the true value. And this one, the errors between the observed value and the true value occurs frequently for your surveying work. Actually, there will be two potential errors to cause the inaccuracy. One is the systematic error. The other one is the expected possible deviations from the true values. For example, for the system error, it could be the something that you're not aligned, some problems that you're not aligned very well, or you did not adjust about the instrument very well. But with as we described in the previous class, for the system error, you can actually find out the correction. So with the correction, so that will be the possible. This will be the potential correction that you can apply. With the correction, you can always correct the observation back to the true values. So we are able to solve the systematic error from the correction. And if you have some expected possible deviations, still we are able to quantify them. For example, like there will be some physical limitations of the surveyors or some potential errors for the instruments itself. We can always find a way to solve it. So regarding to the accuracy, as what we stated here, we have several ways to solve it. And actually, in the future slides, we will tell you how to operate the instrument to minimize the potential errors in the measurement so that we can improve the accuracy. Okay, so that will be all about the Node 3, and I want to save some time. we have 10 minutes left, and I want to have some time left to introduce the field experiment. So what kind of things you need to pay attention about the lab? So I have just uploaded the group list on Avenue to Learn. As I stated at the beginning of the class, there might be some errors because I check all the inputs manually and may mismatch the name. So if we find out any errors about the your group assignment, so let me know. And if we find out any potential errors, send me email to me. I will do the adjustment. And please send me email maybe like today. Try to send me all the requests by the end of midnight today, so that I can finalize all the list, and you can have some time to communicate with your team members and try to prepare for the lab next week. So there will be something you need to know about the lab, the field practice. First of all, there will be some basic procedures you have to know, like you need to have you need to plan and design the survey, which means that you have to read the lab instructions. And at the lab, you need to follow the instructions from the lab technician and the TAs. They will give you some instructions about how to take care, how to handle and adjust the instruments. In our lab, we will mainly apply 3 instruments, the tape, leveling, and also the level transit and the total station. And also, when you do the experiment, you need to fix the horizontal locations and elevations of the object, find out some reference points, and more importantly, you need to record all the values you observed in the experiment, and record them in your field book or in the notebook that you bring to the field. And before you return the instrument to the lab, you need to do some quick calculation in the field to verify whether the data is reasonable. This will help you to exclude any potential human errors or any fault that you made in the field. And once you bring all the data back to the lab, you have to using the office computation with some of the computational tools to find out the to finish the task of the surveying. And also you need to set the point. What the last 2 steps will be the real construction work. You have to set a point as what you calculated in the field project and perform the final as-built surveying. So for the planning and design, there will be several things you have to pay attention. First of all, you need to specify the accuracy for the horizontal and vertical measurements, and to make sure to identify what's the minimum values that you can you will accept. And also you need to locate and analyze all the existing control map, photographs, and the other surveying data, which means that you need to find out some reference points. And well, in the plan design part, you need to select those equipments. And of course, in our lab, we select the equipments for you, but you need to know why. You also need to do some preparation to see why we have to choose this instrument for this type of the experiment. And also the method for you to do the computation, for you to complete the drawing is also very important. And in the lab, we have some basic concept like the taping, which would be the one for you to use the tape. The flagger will be the person who holds the flag to indicate the location you want to measure. The road person will hold the road for at the specific location that where you want to measure. Foresight and backside, we will have more introductions about what is foresight and backside. And the gradient and the gradients, we will try to measure the slope of the surface And also the hub is defined as the station where you want to place your instrument, like the transit level and the total station. And the line would be the things you want to measure, either the distance or the curve. And also you have the turning point where you want to measure the angle. And the benchmark is the reference point. And I will skip several slides and will introduce more in the next lecture. But there will be some very important thing I want to let you know for the field experiment. So for the first day you went to the lab, please bring the print out the lab instruction. It will be very convenient for you to check the paper version of the instruction in the field so that you can know what kind of task you have to do. And also bring some notepads or some blank worksheets. Our lab technician will also provide some the field book, and you can go to the lab and pick up the field book based on with the group number that is assigned to you. In the field book and also for the notebook that you bring to the lab, you need to write down the your name and the numbers, the student numbers in the field book, and also clearly mark the page number for each sheet, and specify the role of each person is doing for each task. Say that which one is holding the rod, which one is operating the total station, and so on. And also you have to write down the weather conditions, whether it's sunny, it's cloudy, raining, what's the temperatures in that day, and so on. And you also have to make a rough drawing or sketch about the areas you are doing the surveying, so that you can have some ideas about what kind of shape of the areas you are working on. And try to make sure that all the recordings that you made for the experiment is needy. With that, we are able to you are able to find out the meaningful values. You did not make any mistake in the after you return back to the office. And try not to erase anything from your field note. It's very important for you to keep all the raw recording, and it will help you to go back to check what's the potential errors at each point that you have made. And do not leave any blank page for the field book. It's quite confusing there. And also record the equipment, what kind of equipment you're going to use, the series numbers, and so on. So this will, if there's any potential errors from the equipment, you can quickly know how to check the potential issues for this type of the equipment online. And so that's the things about the field book. It's very important. And also for the in the Avenue to Learn, I also uploaded a lab schedule. So you can go to there to check at every week what kind of which lab you have to work with. Actually, we only have 5 sets of the leveling transit and the total station. So which means that we can for some sessions there will be more than 5 groups. So we cannot allow all the groups to do the same experiments at one session. So we need to rotate to use those instruments. So I guess that's pretty much everything I want to share with you. And we as you will see that we will have 5 labs: the taping, leveling, transit, horizontal curve, and the topography. I also shared with you about one YouTube playlist. That's the video we recorded last year. You can go to check the watch the video and see the detailed procedure. Also in that playlist, there's one safety video. You have to watch the safety video before you enter to the lab. And one more thing, I believe most of you will bring the backpack to the to conduct the experiment. We actually have a classroom at ADL lab, which you can actually leave your backpack in the classroom. But in order for you to enter the classroom, you have to wear a mask. So that's the only requirement. Also, for the homework assignment, the first homework assignment will be uploaded to Avenue to Learn on tonight, and the deadline will be next Friday. So we have 1 week to work on the homework assignment. So any other questions? Again, if anyone has some errors about the find any errors about the lab group assignment, send me email and I will try to correct. Also in the email, please specify which session you will attend.
Question. How would I know when, for example, session 1 would be?
The session one, in the lab assignment, we listed the number of the session, the time of the sessions. Session 1 is a Monday morning, 8:30 to 12 to 11:20. 2 is a Tuesday morning, and 3 is a Tuesday afternoon.
Thank you.
Okay, so one important note: if you find out any error in the group assignment, send me email and I will correct them and re-upload the group list. So let's try to finalize everything before tomorrow. Okay. Okay. So if there's any questions, I will close the meeting today. And thank you very much for your time. And I will see you next week.